Chapter 2, Common Home Comfort Issues and Causes. The first thing we're going to discuss in this chapter are the two main categories of improvements that we'll consider for your home, and then we'll cover how to prioritize the comfort improvements that we recommend. In the world of building science, your options for improving your home fall into two main categories. The first is what will reduce your electric and gas usage overall, and the second is what will actually improve your home's comfort issues. For example, replacing old light bulbs with new LED versions or replacing an older kitchen appliance or a laundry appliance, that'll lower your electric consumption, but they won't really make you significantly more comfortable indoors. The question that you have to ask yourself is, what issue is most important for me to solve first? Typically, the main answer to that question is going to be improve comfort and not necessarily to save electricity. So that's what we're going to focus on throughout this course. Now we're going to discuss what the shell of your house is and how it relates to the comfort issues inside your home. Over my career, I've earned several certifications from building science-based organizations like ResNet, BPI, and NCI, and all these organizations agree that focusing on improving the shell of a house is where you start first when you want to improve the comfort, health, safety, and efficiency of your home. Shell work happens first, then you focus on the duct systems and heating and cooling equipment. So what exactly is the shell of a house? The shell is basically the materials that make up the roof, exterior walls and ceilings, and the foundation of the house. Think of it as what separates the indoors from the outdoors and keeps the rain from leaking inside. Improving the shell should be done in the following order and includes ensuring proper drainage. Rainwater should drain freely from roofs into gutters and downspouts, onto walls, around and above windows and doors, and ultimately move away from the perimeter of the foundation. This step must be addressed first to avoid creating any problems later on after air sealing and insulation work is done. Air sealing's next. All gaps, holes, and cracks in the ceilings, foundation walls, rim joists, and exterior walls should be air sealed properly and in that order. The next would be adding insulation. After air sealing work is done, add insulation to the ceilings or roof line, foundation walls and rim joists, and then exterior walls. Again, do it in that order. Now that you understand what the house shell is, here are my overall guidelines to follow to make your house more comfortable. Air seal all penetrations going through the upper ceiling of your house and insulate it really well first. Any attic hatches or pull down stairs should be sealed off or weather stripped and insulated as well as you can, ideally to an R30 insulation or more, depending on your climate zone. If you have drywall, all the top plates of walls that are accessible from the attic should be air sealed to the drywall from the attic side with expandable foam sealant or silicone caulk. If you have plaster walls and ceilings, then this really isn't an issue. All electrical, plumbing, low voltage wires, ductwork penetrations through the top plates and the drywalled ceilings should be air sealed with expandable foam sealant or silicone caulk to the drywall. If you have what's called chases in your house, where flue pipes and other things like ductwork run up through them into the attic, the top of the chase must be blocked with a solid material and air sealed to the surrounding framing at the ceiling level. Air sealing is going to be covered in more detail in Chapter 5, so don't worry. If there is ductwork located inside your attic, do not proceed with adding insulation until the ductwork is sealed up or fixed as needed. And if ductwork is present, you also need to decide if it makes sense to condition your attic space by removing all the existing insulation and installing spray foam insulation to the underside of your roof decking. You'll learn more about this in Chapter 6. If you do have ductwork located outside the living space, like in the attic, a crawl space, a cellar, or a garage, then that ductwork should be air sealed at all connections and insulated properly. This is also the time to address any pressure balance issues you may have from one room to the next. This is often caused by too much or too little airflow going into a particular room, which is the result of a poor duct design and leaky ductwork generally. If doors open or close themselves when your system turns on, that's a sure sign of a pressure imbalance between rooms in your house. We often find that the main trunk lines and junction boxes are the bigger problems and are often undersized for the airflow that the furnace or AC system needs. If the ductwork is accessible, you can increase or decrease the size of the ductwork as needed to fix the imbalance. Other ways to correct the pressure imbalance is by installing transfer grills through bedroom walls or doors, or by installing what's called jump ducts in the ceiling that allow air to move from the rooms to hallways and common areas. We'll cover more on this in Chapter 8. If you have a basement, cellar, or crawl space foundation, the next step is to air seal the rim joist to the foundation walls, and ideally do this with spray foam insulation. The foundation wall should be insulated with closed cell spray foam, or foam board insulation preferably. Now let's discuss the 7 most common comfort issues that we're going to solve in this course. Number 1 is hot or cold rooms and floors. Number 2 is drafty windows. Number 3 is leaky doors. Number 4, sweaty windows and stuffy rooms, which are basically high relative humidity issues. Number 5, funky smells, dust, and indoor air quality problems. Number 6 is loud or annoying sounds from heating and cooling systems. And number 7 is snow melting quickly, icicles on roofs or gutters, and frost forming inside attics. Let's start with number 1, hot or cold rooms and floors. Many houses have 1 or 2 rooms that are warmer or colder than the rest of the house, and this can happen for several reasons. Often the second story of a 1.5-story home is much warmer in the summer and colder in the winter. Same with the top floor of a 2.5-story house. Another example is rooms located over garages, which are referred to as bonus rooms. They're notorious for being poorly insulated and uncomfortable almost all year round. The most common culprits of this issue are poorly designed duct systems, where not enough air is getting to or from those rooms or floors, which can be explained in Chapter 8. A lack of insulation surrounding that room or floor, which is going to be explained in Chapter 6. Leaky windows, exterior doors, or attic hatches located inside those rooms, explained more in Chapter 5. Floor cavities or joists connected to attic spaces, over attached garages, over ventilated crawl spaces, or part of cantilevers that are exposed to outdoors, covered in more detail in Chapter 5 as well. Also, solar heat gain in rooms facing south or west without proper shading cause comfort issues. We'll discuss those more in the next chapter. Houses that are built on concrete slab foundations also tend to have cold floors in the wintertime, as the concrete in older homes was not insulated, and even in newer homes it's only minimally insulated around the perimeter. There really aren't good ways to improve the insulation on slab foundations, so your best bet is to make sure the bottom plates of the exterior walls are air sealed well to the concrete floors. We'll cover this more in the air sealing chapter. Number 2 are drafty windows. This is a hot topic and often the very first thing that people assume is the main cause of their home's comfort issues. While windows can certainly be leaky, we often find that they're not the biggest source of the comfort issue. And more often than not, there's no need to spend thousands of dollars replacing windows just to reduce air leakage through them. After testing thousands of houses for air leakage, what I found is that most of the air leakage doesn't actually happen through the window itself, rather it happens around the windows, specifically between the wall framing and the window frame. This area is accessed behind the window trim where the window meets the wall framing. We see this air leakage most often at the top and bottom of window trim because those are areas that don't get caulked before painting, simply because they're not areas that you can normally see without ducking down and looking up or getting on a ladder and looking down over top of it. If the window was never sealed to the surrounding wall framing when it was first installed, then air will leak around them and come into your house where the trim is not sealed. The easiest solution is to apply siliconized latex caulk where the trim meets the wall on all sides, making sure that the trim is also sealed to the window on the interior side. If your window is too close to a wall corner to caulk that gap, you'll have to remove the window trim first and then fill the gap behind it with minimal expansion foam. Then you can reinstall the window trim and caulk it as best you can to the wall. If you find that fiberglass insulation was stuffed in the gap between the window frame and the wall studs, use a flathead screwdriver or even the hook on a clothes hanger to pull out the fiberglass first, and then fill the gap with minimal expansion foam or siliconized latex caulk. Discuss the different types of windows. Different types of windows can leak in different locations. The most common window type is called a vertical slider, meaning you lift the lower portion of the window up to open it. If both the top and bottom sections of the window move, it's referred to as a double hung window. And since there are more moving parts to them, these windows tend to be a little bit leakier than single hung windows, where only the bottom half of the window opens up. Casement style windows open to the outdoors on a side hinge. just like an exterior door. This type of window tends to be more airtight than vertical sliders because there's less moving components to them, and therefore fewer locations where air can leak through them. The most common places you'll find air leakage on these windows is through the top or the bottom, where the window itself meets the surrounding casement frame. The easiest and most cost-effective way to seal these windows better is by using what's called rope caulk or cord weather stripping, where you push this flexible material into the gap as a temporary fix. It can be easily removed and reinstalled without damaging the window or the rope caulk material itself. Horizontal slider windows are built the same as vertical sliding windows, but they only move left and right instead of up and down. The same recommendations for vertical sliders apply here to the horizontal ones as well. Number 3 are leaky doors. Exterior doors have the same issue with regards to air leakage behind the trim surrounding them, and the same recommendations apply here for sealing up door trim. Exterior doors should also have what's called weather stripping on the top 3 sides of the door, the left, the top, and the right, to seal that gap between the door itself and the surrounding door frame. On older houses like those built before the 1960s, the only weather stripping these doors had was a thin piece of metal to bridge the gap, and metal is a very poor air sealing material to use in this way. If this is the case in your home, you might consider replacing the metal weather stripping with an upgraded weather or synthetic version that will air seal more effectively. These can be purchased at Home Depot, Lowe's, Menards, any kind of hardware store. Lastly, with door weather stripping, the part that seals the bottom is called a door sweep. The door sweep is usually 1 to 3 inches tall and can be installed either directly to the underside of the door or to the interior side of the door, depending on the style. The point is the door sweep should bridge the gap between the door threshold or the floor when the door is shut. Number 4 is sweaty windows and stuffy rooms, also referred to as high relative humidity issues. Sweat on windows is referred to as condensation and typically appears on the interior side of the window in the wintertime, when the exterior surface temperature of the glass gets colder than the dew point temperature of the air indoors. You see this all the time when you have a cold beverage with ice in it and the outside of the glass is cold and starts to sweat. So what exactly is dew point? The dew point is the temperature that the air needs to be cooled to in order to achieve a relative humidity of 100%. As we discussed previously, when relative humidity reaches 100% outdoors, then it's basically raining. And indoors, it creates condensation on any surface that is below the dew point temperature. Windows have one of the lowest R values of all the surfaces in your home, and because glass is not porous, meaning it's not able to absorb moisture, like drywall or wood, water vapor in the air materializes on the inside surface of it. The key here is the more humidity you have in your house, the more likely you are to have windows sweating when it's cold outside. So the goal here is to maintain the relative humidity indoors between 40 and 50% year-round for optimal comfort, but that does not mean that your windows will never sweat. What? The reality is, if it gets cold enough outside, nearly all windows will eventually show condensation on them. Older single-pane windows have the lowest R value and should be upgraded at some point to double-pane windows, preferably ones with insulated frames. Most homes built today and over the last 40 years or so have double-pane vinyl framed windows. Triple-pane windows have marginally higher R values than double-pane windows, but they're very expensive, and in my opinion, they're not worth the additional cost when you could put that extra money towards another upgrade that's more cost-effective. So where does all this humidity come from inside the house? The most common sources of humidity are crawl spaces and cellars without vapor barriers over the ground, bathroom and kitchen exhaust fans not working properly or no fans at all, leaky clothes dryer vents, boiling food and water, excessive air leakage to and from attic spaces, crawl spaces, and outdoors, and oversized air conditioning systems. Let's discuss number 1, crawl spaces and cellars without vapor barriers. There is almost always some amount of moisture under the ground, and the purpose of a vapor barrier is to prevent that ground moisture from evaporating up into the house. Even if the ground in your crawl space looks dry to you, it can be deceiving, and it's still likely allowing moisture from further below to evaporate into your house. So properly installing a good vapor barrier is essential to controlling moisture. Number 2, bathroom and kitchen exhaust fans not working properly. This is one of the most overlooked issues we find in houses because people assume that if the exhaust fan is turned on, that it's actually working. The reality is most exhaust fans will only move about half of what they are actually rated to, and this is mainly due to the way that the exhaust duct attached to the fan housing is run out of your house. Even well-installed exhaust fans will rarely move the amount of air that they're rated for, so we generally recommend installing larger exhaust fans than you think you need to make up the difference. In brand new homes, we often find that exhaust ducts are kinked, bent, crushed, or simply way too long to move the amount of air to outdoors that they should. There's a lot of science behind how air flows through ductwork, including exhaust ducts, but the main thing to know here is that flexible ductwork restricts airflow more than solid metal ductwork. And the longer the exhaust duct is, the more turns and bends are present, the lower the airflow will be through them. The best case scenario to get your exhaust fans working properly is to use straight metal or PVC pipes from the fan housing for the first 5 feet at least, and ideally the entire way out. And reduce the number of turns that duct needs to make before exiting your house. Never allow exhaust ducts to terminate inside an attic or a crawl space. This will dump humid indoor air into these spaces and can create conditions that will grow mold and mildew. Always run the exhaust ducts outside of your attic, preferably through a gable end wall if you have one. If you don't have a gable end in your attic, you can run the exhaust duct out through the roof or through the soffit, but just make sure to install a backdraft damper on the end of the duct before it goes out of the attic. That way you won't get outside air coming back in through your exhaust fan into the house. Number 3, leaky clothes dryer vents. The same premise as the exhaust fan applies to clothes dryer vents, but the difference here is there is very hot and humid air leaving the clothes dryer, and if it doesn't make its way all the way out of the house, it can very quickly raise the temperature and relative humidity inside your home. More often than not, the exhaust ducts connected to clothes dryers are not cut correctly to fit the space between the clothes dryer and the connection in the wall where the air is supposed to go out, which leaves a lot of extra flexible ductwork that ends up getting kinked or smashed behind the dryer. If this is the case in your house, you need to move the clothes dryer away from the wall, measure the distance between the port and where the dryer will be, and cut the exhaust duct so that it only has about 6 extra inches of space to connect the dryer to the port inside the wall. This can be difficult to do because of the limited space behind the dryer and the fact that the exhaust port is usually at the bottom of the dryer and wall behind it, so you might need some help to do this properly. Make sure you use a metal clamp to secure both ends of the exhaust duct to the dryer and to the port in the wall. Do not use duct tape for this purpose, as it will eventually lose its hold and blow off one of the ends. Number 4 is boiling food and water. If you like to boil food, you probably already know how much moisture it releases into the air inside your house. If you don't have an exhaust fan in the kitchen, like a range hood, then opening a window is your next best option to let the moisture escape outdoors. If you live in a hot, humid climate, opening a window will probably allow more humidity inside from the outdoor air, so an exhaust fan is the best solution during summer months. Number 5, excessive air leakage from attic spaces, crawl spaces, and outdoors. This is a big source of the humidity in a lot of homes, especially older ones. In fact, the older the house is, the more air leakage there's generally going to be, and therefore more moisture from outdoors and hot attics in the summertime will make its way indoors. Where to air seal the house will be covered a lot more detail in Chapter 5. Number 6 is oversized AC systems. This one is often overlooked simply because most homeowners have no clue whether or not their AC system is too big for their house, so they often look for other possibilities for the cause of their humidity issues. A lot of heating and cooling contractors frankly don't understand this either, and will attempt to sell you on a bigger AC unit to fix the problem, when in fact a smaller AC unit is probably what you need. In order for your AC system to properly dehumidify the air inside your home, it has to run for at least 15 to 20 minutes, and the longer it runs, the more moisture it will remove from the air. Chapter 7 will cover all about heating and cooling systems in greater detail. Comfort issue number 5 is funky smells, dust, and indoor air quality problems. As a general rule, the higher the relative humidity is inside the house, the more likelihood there will be indoor air quality problems. The source of these issues typically come from poor ventilation in bathrooms, kitchens, and laundry rooms, excessive air leakage with outdoor pollutants nearby, as well as from duct leakage from attics, crawl spaces, and cellars. Let's go through the first one, pets. Sometimes you'll get smells coming from unusual places like cat litter boxes that are located near return air ducts inside the house. Obviously, you can fix that by moving the litter box further away from the return air duct. 2. Dry plumbing drain traps. Another one we see frequently is a putrid smell coming from the lowest level of the house, especially those ones with basements. And this often happens when there is a bathroom in that lower level that's not used very often. Basically what happens is the plumbing drain line has a trap that dries up due to lack of use, and it allows sewer gas to get sucked back up into the house through the dry drain pipe. The more stack effect a building or a house has, the greater the negative pressure will be in the plumbing lines at the bottom of the house, and that negative pressure is what sucks the sewer gas back up through the pipes. We'll explain stack effect more in the next chapter. All you really need to do to fix this issue is run water down the sinks and bathtubs or showers on the bottom floor of your house to fill the traps back up again, and the sewer gas will be blocked there at the traps. You may also want to call your water utility company if that doesn't fix the issue, just to make sure that there is a backflow check valve where your house's main sewer line connects to the street main line. Older houses may not have been built with them, and over time tree roots can break them apart, causing backflow issues as well. The third source of funky smells are from carpet and rugs. Dirty carpet and floor rugs are other big ones, especially if you have pets in your house. Carpet fibers can trap dust, dirt, pollen, pet hair, and dander inside them, and if the carpet ever gets wet, it's more likely to be a breeding ground for mold, mildew, and other nasty things. Hard floor surfaces like wood and tile are always easier to clean, and in high traffic areas it's best to use them there instead of carpet for more durability long term. The fourth one here is ductwork and heating and cooling equipment. Ductwork in the furnace inside your house or other places that can get dirty inside as they run over time. Regularly changing your furnace's air filter and having ductwork and HVAC components cleaned out professionally every so often are important to keeping dust and contaminants from accumulating inside and spreading throughout your home. If your ductwork has insulation on the inside of it, which we generally don't recommend, it will also gather dust and other airborne contaminants in the insulation as the air moves through it. And if there's also a humidity issue inside your house, the contaminated insulation can be another breeding ground for mold, mildew, and fungus, which is gross. Leaky ductwork that's located in crawl spaces or attics can also suck in pollutants from those areas and not only bring funky smells into your house, but dust, pollen, humidity, and even insulation fibers that you certainly don't want to be breathing constantly. The sixth category of home comfort issues that we're going to cover are loud heating and cooling systems. While these aren't what you might traditionally think of as comfort issues, loud or annoying noises inside your home can certainly reduce your peace of mind, making you uncomfortable as well. There are lots of noises your heating and cooling system makes, and we're going to separate the reasons for them into three main categories: rattling and vibrating noises, large heating and cooling systems, and undersized ductwork. Let's go through the first one now, rattling and vibrating noises. Here are the 5 most common causes of rattling and vibrating noises in heating and cooling systems. Number 1 is unlevel equipment. Number 2 is supply air registers and return air grills. Number 3 are airflow dampers. Number 4 are restrictive air filters. And number 5 are AC condenser line sets. Number 1, unlevel equipment. One of the most common noises you'll get have to do with the air conditioner's outside condensing unit. This is the metal device just outside your house that spins to release the heat from your house in the summertime. If you have a heat pump system, this is the same outdoor unit. A lot of times these condensers are not placed upon a solid and level surface, and if they're angled too much in any direction, the spin will get off balance, creating metal rubbing or grinding noises, and wear out the unit faster than it would otherwise. Number 2 is supply air registers and return air grills. Another noise that you'll hear often comes from the supply air registers and return air grills throughout your home. They're typically made of metal and are in direct contact with the metal ductwork behind them. So if the airflow in the ductwork creates a vibration, it will sometimes rattle the supply air registers and the return air grills. Number 3 is airflow dampers. Less common but still worth noting is vibrations coming from airflow dampers located inside some supply air ducts. If you have a basement, you might actually be able to see the airflow dampers if your basement ceiling doesn't have drywall up. They can also be found in systems located inside attic spaces. Airflow dampers are installed to adjust the amount of air going through the ductwork into a room, and they're an important part of an air balancing procedure. You'll learn more about air balancing in Chapter 8. The dampers inside the duct are typically connected to a small metal handle outside the duct, and when you turn the handle perpendicular to the length of the duct, it will prevent most of the air from flowing around the damper. Sometimes these dampers are motorized and controlled automatically, and this is typically when you have a zoned heating and cooling system. If you have airflow dampers that are hearing noises coming from the ductwork, you can listen closely to the noises to find which supply register the sound's coming from the loudest, and then go locate the damper lever in the basement or the attic connected to it. Turn that lever slightly and have a friend or a family member listen inside the house to see if the noise gets better. Once you find the right spot, you can stop adjusting the damper and mark the spot where the lever is on the ductwork insulation for future reference. And here's a pro tip. Call each other on the phone or FaceTime each other while you're doing this. The person in the attic should use a Bluetooth earpiece so that they have two hands to support themselves at all times for safety. Number 4 on noises is restrictive furnace air filters. This one's pretty common as well. If you buy air filters that are too restrictive, it will reduce the airflow through the equipment and increase the internal static pressure inside the ductwork and the HVAC equipment. Internal static pressure in heating and cooling systems is similar to blood pressure in humans. The higher it gets, the more likely something's going to break, and the marketing message most consumers see about air filters is the more efficient they are, the better they can reduce allergens, dust, and other things inside the air. These filters are marketed as high efficiency or allergen reduction air filters, and they usually have a MERV rating on them, which means minimum efficiency reporting value, indicating the higher the MERV rating, the better they are for your HVAC system. Most of the time though, they are not better for your system and can actually cause more problems than they help. Often they make the system noisier due to the strain they create on the system's blower wheel that moves the air through the furnace. In general, using media filters that are 4 or 5 inches wide will give you the best air filtration and airflow for the money. If your system has a normal 1-inch wide air filter rack, you'll have to upgrade to a new media filter rack to use these kinds of air filters. It's best to do this when you install a new furnace or a heat pump, but they can be added to existing systems too without too much trouble. For 1-inch thick air filters, stick to basic fiberglass ones with a MERV rating of 8 or lower to ensure good airflow. You'll learn more about air filters in Chapter 7 and 8. Number 5 here is AC condenser line sets. If you have central air conditioning and or a heat pump system, you have an outdoor condensing unit that spins in a metal box somewhere outside your house. The thing that connects your outside condenser to the inside air handler, which is the device that moves the air through your ductwork, is called the line set. The line set typically runs through attics, basements, and sometimes between floors, through exterior walls and out to the condensing unit. Often the line set is secured to the framing inside the house or it's connected to the side wall of the house. So if the outdoor condenser has a vibration issue, it will radiate that vibration into the house through the line set. Since the line set is also connected to the AC equipment and the air handler indoors, it also therefore connects to the ductwork. So again, any vibrations from the outdoor condenser can ultimately vibrate the ductwork inside the house as well. The best thing to do here is to make sure the AC condenser is completely level to the ground on all sides, and have a qualified HVAC contractor ensure that the entire system is balanced during your next tune-up. The second main category here is large heating and cooling systems. In general, the larger the furnace is inside your house, the larger the AC system will also be, and the more airflow each system will need to operate efficiently. It takes more energy to move more airflow, so larger furnace fans will tend to create more noise, especially when they're connected to ductwork that's not big enough for it. The only solution you really have to reducing the size of your heating and cooling system is replacing the larger equipment with a smaller one. When you have the opportunity to replace HVAC equipment, you should always consider upgrading to dual fuel or hybrid systems that consist of a heat pump with a gas furnace backup for that heat, if you live in the middle or northern parts of the country that get really cold. If you don't have gas service to your home and you just have an electric furnace with central AC, you should absolutely upgrade it to a heat pump system when you can, as it will be much cheaper to heat your home in the wintertime. Whether you choose a hybrid system, a regular gas furnace with AC system, or a heat pump system, you want a new HVAC system to have at least 2 stages of heating and cooling capacity with a variable speed fan, as these features make the systems operate much more quietly and efficiently versus regular single-stage systems. They are also better at dehumidifying the air inside your home, which is obviously very important. The third major category here is undersized ductwork. If you've ever tried to swim in a pool or the ocean with a snorkel in your mouth, you know it's not nearly as easy to breathe through that tube as it is to just breathe normally. And if you have bigger lungs, you may struggle to bring in enough oxygen to stay relaxed underwater. Now imagine trying to swim underwater with a snorkel the size of a plastic straw. It would be impossible to breathe properly and you'd quickly suffocate. The straw would collapse under your sucking pressure and you'd wish you'd stayed on the beach with a tasty drink instead of risking your life snorkeling. What does this dramatic scenario have to do with ductwork, you ask? Well, when you have ductwork attached to a furnace that is not big enough to move the amount of air necessary for proper function, it chokes the system and can create a banging noise from the return side of the ductwork when the system turns on and off. And the restricted airflow will cause the ductwork in the furnace itself to vibrate or rattle. The supply air side of the ductwork can have the same issue too, but we normally see this on the return side of the ductwork, and especially in homes built before air conditioning was standard. See Chapter 8 for more on duct systems. The last comfort issue that we'll cover here is snow melting quickly from your roof, icicles on your roof or gutters, and frost that forms inside your attic. If you've ever noticed in wintertime that the snow on your roof or your neighbor's roofs melts faster than most other houses nearby, it's a sure sign of excessive heat loss through the top floor of that house. Most of the heat loss comes from big air leakage paths from inside your home up into the attic above, and or insufficient insulation on the ceilings up there. Once that warm, humid air is up in the attic in the wintertime, it'll naturally be drawn to the coldest and driest surfaces nearby, which are the roofing nails, roof decking, and all the wood rafters, studs, and joists. That humid air clings to these surfaces, and as the air cools down, frost can form on the nails, studs, and roof decking as a result. The biggest sources of air leakage and heat loss into attics are recessed lights, attic hatches, chases where ducts, pipes, and electric are run through, bulkheads and soffits, vaulted ceilings, leaky ductwork, heating and cooling systems located inside attics, and poorly insulated ceilings. If your house tends to have icicles hanging from the lower edges of your roof or gutters, then the sources of the problem come from the same list that we just discussed. These icicles form due to a concept called ice damming, which typically happens when the insulation above the ceilings in your house located at the perimeter edge of the attic are poorly insulated. When this happens, more heat is lost at this roof-to-wall intersection, which melts any snow or ice that might be on the roof directly above it. When the snow melts and starts to drip over the edge of the roof, if the air outside is below 32 degrees, then the water dripping will refreeze, and if this continues on, the melting, refreezing pattern creates icicles over time. You'll also see this on gutters if there is a leaf guard on the top or they're otherwise full of debris or snow. That covers the main comfort issues we're going to address in this course. The next chapter up is on building science basics, and I can't wait to see you there.